Hyperconjugation. Hyperconjugation is one of the most important topics of mechanism of organic reactions. Uh, Before going to the definitions of hyperconjugations, anything type of hyperconjugations, effect of hyperconjugations, we will learn something basic about hyperconjugation to understand what is actually hyperconjugations. Before understanding what is definition, we will learn some things basic about hyperconjugation, then we will proceed further. Here in this hyperconjugation, these are 1 2 3 4 groups. This is a tertiary carbon, a secondary carbon, primary carbon, this is a carbon. As from this, if you this is a primary, secondary and tertiary carbon. This methyl group attached with this carbon, this methyl group, this two methyl group, there is 1 2 3 methyl group. Here is the one methyl group. It will provide positive I effect, it will provide 2 positive I effect, it will provide 3 positive I effect. In this way, the I effect, from this the increasing the order of I effect. If you proceed in this direction, right direction, from this directions, there is an increase of positive I effect. If any group will be attached with this, then it will feel more I effect, it will experience more I effect in this group, then this group, then this group. In this order, as the group, here is a group is attached, here group is attached, any group will be attached, it will experience more I effect than this increasing order. In this order, this group will experience more I effect. But this group will, if this group will be in a conjugated system, if this group will be in conjugated system, if this group will be unsaturated, if this group will be free radical, if this group will be carbocation, then the order will be reverse. If any other group will be simple group will be there, then this will experience more I effect, more positive I effect. It will stabilize by this I effect, in this order increasing the I effect. But if this is unsaturated, if this group is unsaturated, then the order will be reverse, decreasing hyperconjugations. Decreasing hyperconjugation means if this group will be unsaturated, if this group will be unsaturated means double bonds will be present, yeah, positive charge is present, yeah, free radical is present. If any such type of group will be present in here, then it will experience less hyperconjugations. It will, that's why the hyperconjugations increasing in this order. This group will provide more hyperconjugation than this group, then this group, then this group. This is the increasing order of hyperconjugation, and this is an increasing order of inductive effect. Means inductive effect and hyperconjugations are in opposite. Why opposite? What is happening in the hyperconjugation? That's why the in this order the inductive effect increases, but hyperconjugation decreases. What is this? I'll explain little with one example. This is an example. This is a this carbon is providing the I effect and hyperconjugations. This is providing I effect and hyperconjugation. For this instance, let's don't think about the hyperconjugation. We should only focus about inductive effect. This will provide more inductive effect, this will provide 2 inductive effect, this will provide 3 inductive effect. So this is, we can if you will not know about the hyperconjugation, then you will thinking that it has more stability than this. If you think that stability will be in this order, but here is the one concept is applying hyperconjugation. So the order will be, actually the order will be in this order because of hyperconjugation, because here this methyl group 3 hydrogen is attached, but this carbon has a 3 hydrogen attached, this carbon has a 1 and 2 hydrogen attached, this carbon has a 1 hydrogen attached, this carbon doesn't have any hydrogen directly attached with this carbon. So at alpha position, whatever the atoms will come, that must have one hydrogens, at least one hydrogens for being a hyperconjugations. This has a 3 hydrogens for being hyperconjugations. By the hyperconjugations, it releasing is electron of sigma bond electrons. This is a sigma bonds. The sigma bonds electron will release to this compounds. As the number of hydrogens increases, the hyperconjugations increases. Number of sigma bonds increases, hyperconjugations increases these hydrogens sigma bonds. So this will increase the stability of compound. So as the inductive effect increases, this is the inductive effect increases but the hydrogen decreases. So this where the inductive effect increases but the hydrogen decreases in the alpha carbon which is attached with this group. This is a group, this group is unsaturated, this is a group is unsaturated. This group with respect to this group at alpha positions, if hydrogen, as the hydrogen increases, hyperconjugation increases, but for increasing the inductive effect in this direction, inductive effect increases, hydrogens decreases, so the hyperconjugation decreases. That's why this group is more stable than this is in the increasing order of stability. Now I will tell you, if inductive effect and hyperconjugation both are acting any compounds. Here in this case, inductive effect and hyperconjugation both are acting. Then we have to decide which will increase the stability. If inductive effect and hyperconjugation both are acting, then the hyperconjugation will be higher priority than the inductive effect. Hyperconjugation will be higher priority than the inductive effect. That's why this group is more stable, because this group has a more hyperconjugation. This group has a 3 hyperconjugating hydrogens, but this group is a 2, this group is a 1, this group has 0. That's why this group is more stable. I have already told you that hyperconjugation has a higher priority than the inductive effect. So here is written methyl benzene has a 3 CH bonds, sigma bonds in conjugation with the pi bonds. This has a 2 CH bond, this is a 2 CH bonds in conjugation with the pi bond. This is a 1 CH bond, this is a no CH sigma bond in conjugation with the pi bonds, no hyperconjugation. This has a 3 contributing structure in hyperconjugation. This group has a 6 contributing structure in the hyperconjugation. This has a 9 contributing structure in the hyperconjugation. How the hyperconjugation structure? Here is a 9, here is a 6, how 3? No, I will explain in the detail in the later, but I will little bit explaining you that how this 9 contributing structure. As this is a 1 hydrogens. Now after remembering this, as here is a 1 hydrogens. These hydrogens will generate 3 hyperconjugating structure with 1 bond, 1 bond, 1 bond. It will generate 3, it will generate 3, it will generate 3, total 9. This will generate 3, 1, 2, 3, and this will generate 3, 3, 6. This will generate only 3. This here is no any hydrogens, so no hyperconjugating structure will generate by these compounds. So now we will learn in more details. Baker and Nathan. Baker and Nathan are the scientists, can we call as scientists, who explain about hyperconjugation. We give some information about hyperconjugations. The concept is more clear by Baker and Nathan. That's why we need to learn Baker and Nathan in a hyperconjugations. As the little bit introductions I will tell you, then after I will proceed further example. Baker and Nathan suggested that the alkyl group with at least 1 hydrogen atom attached at alpha carbon with respect to unsaturated carbon. Here is alpha carbon. This is alpha carbon attached with this unsaturated compound. This is unsaturated group with respect to this group at alpha position. If hydrogen is attached, at least 1 hydrogen must be there for being a hyperconjugations. Yeah, positive charge. This group may be unsaturated positive charge, yeah, odd electron. Yeah, positive charge carbonium ion, yeah, odd electrons. Anyone unsaturated positive charge, odd electrons, free radical. Odd electron means free radical, etc. This type of atoms, a group of atoms, are able to release electron by the mechanism similar to the inductive effect but different from the inductive effect. If with respect to unsaturated group, you have free radical, you have positive charge. If at alpha positions at least 1 hydrogen if there, then it is able to release this sigma bond electron to this system, to this unsaturated system, to the free radical, to the carbocation by the similar mechanism of inductive effect. The inductive effect also releasing electrons and providing a stability. This is a similar hyperconjugation, also increasing the stability by providing the electrons of sigma bond electrons, but it is different from inductive effect. It is a similar to inductive effect, but it is different from inductive effects. As this is a hydrogen, this sigma bond electron shift to this position, this pi electron shift to this positions. Now this become negative charge, here this become negative charge, this become a positive charge. This positive charge, this negative charge plus minus will form a bond. Here bond is formed. Here hydrogen will become as a plus. This is a plus. Now this hydrogen will shift to these positions, and this minus will become, and this plus and this minus, this will generate a minus. Actually this I am showing this bond is shifted to this position, but actually how it is happening I'll show you. There is a plus charge, this hydrogen shift to bond shift to this position. Now this plus, this is a minus, this is a plus, this will form a bond. Now H become H plus. Now this is H plus, this is bond is forming. But for direct showing, this bond is shifted to these positions and plus minus will form a bonds. Actually in this way the bond is forming, but here in everywhere in every book it is shown like directly in this manner. So I have shown this manner. If a radical is there, then this radical, this one bond is breaking in homoelectrically, it will break. One electrons go in the hydrogens, one electron go in the carbon. This carbon will get a one electrons, this one electron will form a bond. Now this is a bond, hydrogens become a free radical. In this way it will provide electron to the system, to the unsaturated system, to a free radical, to a positive charge. This type of electron releasing by the alkyl group attached to unsaturated systems, a free radical, a positive charge, is called hyperconjugation. So hyperconjugation definition is clear. What is hyperconjugation? This type of electron releasing by alkyl group attached to unsaturated system is called hyperconjugation. If anywhere examinations is asked about the theoretical theory about what is hyperconjugation, then we can explain the Becker and Naphthens. If Becker and Naphthens suggested alkyl group attached with at least one hydrogen atoms, this definition, the condition is that at alpha position must be at least one hydrogen. If two hydrogens will be there, then more hyperconjugating structure will be formed. If one will be there, then less hyperconjugating structure will be formed. But definitely there will be hyperconjugation if one CH bond will be there at a alpha positions. Now Becker and Naphthens explain more about the hyperconjugation. Till now we have learned about the hyperconjugations, but it will explain more about the hyperconjugations. Hyperconjugation is a special type of resonance, in which decoalization of electron takes place through overlap between sigma bonds orbital and pi bond orbital, p orbital, sigma bonds orbital and pi bond orbital. There is a overlapping between sigma bonds orbital and pi bonds orbital. I will explain in detail. This is a sigma bonds orbital, this is a pi bonds orbital. There is a overlapping between this sigma and pi bonds orbitals. In this way they are sharing the electrons and transferring the electrons and providing electrons. In resonance effect, decoalization of electrons occur through pi and p pi overlap. There is a pi p pi overlap is there in the resonance, that is pi electrons are involved in the decoalizations. In the resonance there is a pi electrons are involved in the decoalization, but there is a sigma bonds electrons are involved in the decoalization of the in the hyperconjugation. Hyperconjugation, sigma bonds electrons are decoalized, the sigma bonds are shifting. Now we discuss the decoalizations of sigma electrons through sigma pi and sigma p orbitals. Sigma pi orbital means here is a in sigma, this is a sigma bonds orbital, pi bonds orbital, there is a overlapping and transfer of electrons, knowing as a hyperconjugation. This is known as hyperconjugation. The sigma bonds in the conjugation with the pi bonds. Sigma bonds is a conjugation with the pi bonds, I have already explained. Sigma bond is conjugation with the p orbitals, vacant or p. Sigma bond is conjugation with, I have already explained, there is a pi bonds, maybe unsaturated system, maybe free radicals, maybe carbocation. So sigma bonds in conjugation with the p orbital, vacant field orbitals, participate in the decoalizations and thus stabilizes the system. Participate in the decoalizations and stabilizes the system. The process is similar to the resonance but extended to a sigma bonds, therefore named as hyperconjugations. This is similar to the resonance. Resonance also decoalizing the electrons, pi electrons are decoalized and stabilize the compounds, and hyperconjugation also decoalizations is taking place there is, but sigma bonds electrons are involved in the decoalizations. I will explain all these things in the diagram. For example, in the propene molecule, hyperconjugation arises due to partial overlap of sp3 and s sigma bonds orbital and empty p orbitals or pi bonds orbital of adjacent carbon atoms. Here this thing I will explain in the figure. Here here is the figure of propene, meth, eth, propene. There is a propene. Here is the double bond, so it is a propene. This is a p and sigma bonds orbital, this is a p and s orbitals, this is a sigma bonds this is a sigma bonds. This is a sigma bonds. I have already explained. This is a sigma bonds. It is shown in the three-dimensional view. And this pi orbital forming a bonds. This pi orbitals, this pi bond, this is a pi bonds. This sigma bonds and this pi bonds are overlapping to each other. Here is 10. For example, in propene molecule, hyperconjugation arises due to partial overlap of sp3 and s sigma bonds orbital and p orbital pi bonds orbital of adjacent carbon atoms. Here there is a overlapping between adjacent carbon atoms. Here this is adjacent carbon atom with respect to this, and there is overlap of orbital. This is a sigma bonds orbital, this is a pi bonds orbital. There is a overlap. Now here one carbon hydrogen bond of methyl group can lie in the plane of pi bonds orbital, hence partial overlap with the pi bond orbital. Here the carbon hydrogen bonds of methyl group is lying in the plane of pi orbital. Actually here overlapping is there. Why? Because this is a lie in the same plane. Whatever the plane of this pi bonds orbital, it has, and sigma bonds orbital also has the same plane. That's why there is a overlapping between these two orbitals. This result of decollisions of pi electrons increase the stability. That's why that there is a decollisions of pi electrons. This pi electrons will decollize. This pi bond sometimes come this position, this sometimes come this position. So there is a decollisions of pi electrons. So there is a increasing stability. As the decollisions in any compounds, not in hyperconjugation, I am only saying. I am saying everywhere in the organic chemistry. Wherever the decollisions increases, the stability increases. Here the decollisions of this pi bonds is happening in this compound. That's why the stability increases. This is the three-dimensional view, but I will explain that theoretically. This is a propene. Here is a pi bond unsaturated system, and this is alpha carbon. This is alpha carbon has a 3 hydrogens. So there is a 4 hyperconjugating structure is possible. One is this general format. This is a this form, and other will be plus 3 form. Yes, this hydrogen bonds will shift this position. This become a positive charge. Here it is shown. This is a positive charge. Pi bonds are forming, and this pi bonds will shift to this position. Minus charge will be generated. Here minus charge is shown. Now again this pi bonds will shift to these positions, and this will shift to this position. Minus and plus will form a bond. Here is bond is shown. It can become a positive charge. Now this will shift to these positions. Minus plus will form a bonds, and this become a positive charge. Here positive charge is shown. In this way there is a 3 hyperconjugating structure and 1 actual structure. Total 4 structure are there. I will explain this thing. I will explain more detail in there. This is a sigma bonds. This is a sigma bonds, and this is a pi bonds. Sigma bonds and pi bonds are in conjugation. There is a overlapping between this sigma bonds and this pi bonds. There is overlapping. This is a overlapping of orbitals. Sigma orbital, and this is a pi orbital. This is a pi orbital. This is a sigma orbital. This is a sigma orbital. There is overlapping. Now I will explain from these structures. This hydrogens will shift to this position. This bond, sigma bond, shift to this position. This become a positive charge. This hydrogens will shift to this positions. This bond will shift to this position. This minus, this positive will form a bond. Here bond is forming. This become a positive charge. This become positive charge. This is also shifting. Minus plus, this minus plus form a bond. Form, and this become a positive charge. So 1, 2, 3. There is a 3 decollisions of hydrogens. 3 structures, and one is this actual structure. Overlapping between sigma and pi orbital is shown. This is a contributing structure is shown. This is called, that's why this is called no bond resonance. There is a no bonds here in these structures. There is a no bonds. Here there is a no bonds. So this is called no bond resonance. The no bond between carbon and hydrogens, but its compound is exist as in conjugation. That's why this is also can be called as no bond resonance. This the name is also, this is can be called as no bond resonance. I have already explained that. Somewhere is there, but this is also can be called as hyperconjugation, is also called as no bond resonance. In the generating structure of propene, there is a no bond between carbon and hydrogens ion. Therefore, hyperconjugation is also called as no bond resonance. Similarly, in the case of toluene, the carbon-hydrogen sigma bonds of methyl group participate in the decollision with its bonds of benzene ring. The presence of 3 CH bonds in the conjugation with the pi bonds of benzene ring result formation of 9 contributing structure. I will explain this. There is a 1 hydrogens and there is a decollision of these pi bonds. this become a minus, this become a minus, this become a plus. This plus minus will form a bonds. Actually this is shifting to this position, minus, and this plus minus will form a bond. This become a minus, this is minus, and this become a plus, as this bond is shifted to these positions. Now in this way this pi bonds will shift to these positions, minus plus minus will form a bond, this will plus, this will be plus minus will form a bond, this will shift to these positions, minus plus will form a bonds. Here bond is formed, minus is there. Three structures are formed. Now the first hydrogen is involved, now second hydrogen is involved. Here become a, here now this become a minus. This is a three structures. Now this pi bond shift to these positions, this become minus, this become plus, minus will form a bonds, and now it will form a bond. Now it will shift to these positions, minus. Now again the same process will repeat, this become a minus, and this pi bond shift to these positions, and plus minus will form a bond. Again the same thing will repeat. Now this will generate three structures, this will generate three structures, this will generate three structures. Total 9 structures are generated. 9, therefore in all there are 9 contributing structures, 3 for each sigma bonds. For each sigma bonds there is a 3 structure are generated, here I have shown, and in similar way there is a 9 structures are generated. Sigma bonds in conjugation with the pi bonds of benzene. This sigma bonds is conjugation with the pi bonds of benzene, I have already explained. As the number of methyl group bonded to double bond carbon atom increases, the possibility of hyperconjugation increases with the result of more stability. As the methyl group increases, this is a 2 methyl group, this is 2 methyl group, 2 methyl group, 1 methyl group, 2 methyl group, 2 methyl group, 2 methyl, 1 methyl, 1 methyl, 1 methyl, 1 methyl, 0 methyl. As there is a 2 methyl, so it has more stability. It is a 2 1 methyl, it is a more stability than this 1 1 methyl, 1 0 methyl. So as the methyl group increases, the stability increases. That is, the region more substituted alkene are more stable than the less substituted alkene. Means more substituted alkene are more stable than the less substituted alkene. The increasing the order of stability of some alkene is shown here. It is shown one of the example there at the stability how that increases. As the substitution increases, methyl group increases, stability increases. As the methyl group increases, the hydrogens increases. Here the hydrogens increases. 2 methyl group means 3 3 6 hydrogen. That's why there is an increase in hyperconjugation. As the hyperconjugation increases, the stability increases. Now we will learn about what the structural requirement for the hyperconjugation. What is need to be a structure? What the structure need to have for being a to show a hyperconjugation? This I have already explained these things.